In this video I'll solve a projectiles problem. The problem I've written on the board is to calculate the maximum height of a projectile. It's an angled projectile which is launched at 38 meters per second, and when it's at maximum height it has a velocity of 26 meters per second. So using that information I need to find out what the maximum height is. That's what we're trying to find. So let's just remind ourselves of what happens in an angled projectile situation. Because we're neglecting air resistance, which is one of the assumptions we're going to make, okay. And it's a symmetric flight, and it's launched at 38 meters per second at some angle theta that we don't know, and at maximum height has a velocity vector of 26 meters per second. We need to remind ourselves of the conditions at the top. At the top, the vertical component of the velocity is reversing direction. So when it's right at the top, maximum height, the velocity vector is horizontal. So it's horizontal at the maximum height. So, and the other thing about projectiles is that, so I'll just write here as well, the vertical component of velocity is 0. The other thing about projectiles is that there is no acceleration in the horizontal direction. So therefore, UH is constant throughout the flight. So this is horizontal, that's equal to the horizontal component at every step of the way, which includes at the start. So we can use that to find out what our angle theta is, and therefore the vertical component of the initial velocity. So we'll do a bit of trigonometry to begin with. UH is equal to U cos theta. This is 26 and this is 38. We're going to solve this for theta. Inverse cos of UH over U, which is equal to cos minus 1 the inverse of 26 over 38. And so theta then equals 46.8 degrees. We now have our angle theta. We can use that to do a little more trigonometry to find out what the initial vertical component of the velocity is. So UV is U sine theta, and that therefore is 38 times by sine of 46.8, and that value is 27.7 meters per second. So I now have the final vertical component of the velocity, the initial vertical component of velocity. We know that the acceleration is equal to minus 9.8 if I take upwards as positive. So that would be positive, and that would be negative. It's a SUVAT problem because the vertical component velocity undergoes constant acceleration downwards. So we'll write down what everything is. SV, that's what we want to find, the maximum height. UV, we just calculated, 27.7 meters per second. VV, that's 0. And A is minus 9.8 meters per second squared. And T, don't need to note it, because we have four quantities, one of which is our unknown. The equation we need to use with SUVA is v squared equals u squared plus 2as. We're using that fourth equation. Rearrange that for s, which is what we want to know. So s is equal to v squared minus u squared over 2 times a. Put the values in and we'll get the maximum height. So v 0 minus 27.7 all squared over 2 times minus 9.8. You notice because I've been consistent with my direction, I have a negative value on the top because the negative is outside of that squared term, so that's going to be negative there, negative over negative giving me a positive. So S equals 39.1 meters. That's the maximum height. So that was the problem with projectiles, where I had to remember the rules about what happens at the top and what happens to the horizontal component throughout the flight time. And so that's one example problem for projectiles.